Hello everyone, welcome to the third part of the video tutorial series, Learning Pandas from Zero. My name is Sheng-Chi Leung, and in this tutorial I will be your guide in Pandas. Today we will explore together how to access the elements in a data frame. Let us recapitulate what we have learned in our last tutorial. We have covered how to build a data frame by passing a list, dictionary, and a CSV file to Pandas. We have studied some setting which helps us to create the table that resembles with the primitive one. When we print the data frame, it always outputs all the data. In the case of a very large data frame, Pandas will only output the beginning and the end of the data frame. The whole table is not useful if we want to understand a specific part of the data, or use a specific part of the data for our own analysis. Therefore, today we will look at different ways to extract parts of the data from a data frame. Before we dive in the specific method, we will first briefly review how we call the elements in a two-dimensional array, or a rank 2 array in NumPy. As I mentioned in Chapter 1, the introduction, NumPy is closely related to Pandas in terms of the array structure. In a rank 2 NumPy array, we always have two indexes to define the position of the element. The first index corresponds to the row, and the second index corresponds to the column. In the table, I illustrated the position of each cell. For illustration purpose, let's create a random integer array. I like to use this kind of array because it will really help us to distinguish the row and columns clearly for demonstration. Here I use a standard function randint to create a 5x2 array. To call the elements in the array, there are three ways to do so. First, we can call the element by its exact row and column number. For example, row 2, column 1 correspond to element 47. And indeed, if we tried on the Jupyter Notebook, we get an agreeing result. In NumPy, we can call a group of elements by the colon notation. This is the same as a list that you simply state the starting row and column number and the ending row or column number. NumPy generates an array which stores this subarray for you. For example, in the example, 1 colon 3 and 0 will correspond to row 1 and 2 and column 0. Notice that we can only use one colon notation in each call, or otherwise NumPy will complain about broadcast error. The last way to call the element is by a list. We can store a list of rows and columns, and pass them as the index when we call the array. Then NumPy will also form an array to store the data in this subarray. Now we have reviewed how array elements can be called in an array. In Pandas, we apply this idea in the three data frame methods, iloc, loc, and directly as an index. In the following slide, I will refer to the same data frame df for our demonstration. iloc can help us refer the elements by their row and column numbers. Loc can help us refer the elements by their row and column names, that is, headers and indexes. Finally, we can treat the column as the data frame index or attribute. Once we use iloc, we simply pass the ranges or values of the row and column like what we have demonstrated in a NumPy array. Notice that it is possible that we only pass one index. In that case, Pandas will treat it for the row index. Now let us examine the example by calling row 1 colon 3 and column 2. As we have mentioned, the colon here refers to a range, but with the end value omitted. So 1 colon 3 means rows 1 and 2, and column 2 refers to the column strawberry. Combining these two information, this means that we will have the data 22 and 12 as shown here in the slide. Notice that when Pandas return a one-dimensional object, it is not a data frame, but a series. And then we look at one more example. where we pass a list 1 and 3 for the row and 0 and 2 for the column. Naturally, it is a 2 times 2 array, so it corresponds to a data frame. Row 1 and 3 are for row California and Texas, while columns 0 and 2 are for columns store ID and strawberry. Again, combining these two, we get the data frame shown at the bottom. Then, let's move on to examine the method log. The format is exactly the same, but this time we need to pass the data according to their index and headers. For example, if we pass the indices California colon Texas as rows and then strawberry as the indicated column, again, Pandas will search the row starting from California and the ending row Texas. But this time something is different. When we look at the output, there are 3 rows instead of 2 rows. So here is the major differences between the call by iloc and log. For log, the ending value, or to be precise, index, is also included. This gives actually more graphical ways for us to look at the table and call the data more easily, without having to add one more column or row by default. And then when we pass the index and headers in a list for log, Pandas will look for these rows and columns accordingly, and return a data frame or a series depending whether it is a one-dimensional object or not. What happens if we only pass one value like what we do in NumPy? The answer is Pandas will return the whole row for you. That is a very useful feature if we want to do operation for each entry one by one according to some more complicated methods. For example, if we pass only one list containing California and Texas, Pandas will return the entire rows with these indices from the original data frame. Then what if I want to access the whole column? Can I just pass the headers? The answer is no. For log and iloc, they always assume the first one is for the rows. If we want to get the column store ID in this example, we need to write colon, comma first. Now it is your turn to try some exercise. Imagine today the shop manager you're working with handed you with this table shown in the top right hand corner. He wants to get the following 2 outputs but not sure how. Can you help him? The manager wants to know if it can be done by log and iloc. Again, feel free to pause the video so that you can try it on your own. So here are the answers. I hope you may get the correct answer. This time the questions by this manager can be a bit tricky. For the first one, we can simply use the colon notation to achieve the result. Of course, we can also pass a list to specify the corresponding rows and columns. Here I show you the colon notation. Again, notice that the final index for log and iloc are different because of the inclusion or exclusion of end values. For question 2, you may use both colon notation or list notation. This time, I try to mix both notations so that you can see how they work. If you have questions, feel free to let me know in the comments. Finally, the last method is to call by referring to the data frame index. Each of the columns is actually stored like a dictionary in the data frame. Remember, in the last chapter, we have discussed how to pass to the dictionary to form a data frame. In fact, the column header is like the key for that array. And once we have that in mind, we can immediately apply this concept to call one or multiple columns. In the first example, using the key store ID, Pandas will return you a series containing all data along that column. Similarly, if you pass a list like what we have done for the last 2 methods, Pandas will collect these columns and form another data frame for you. However, this method does not support colon notation. The previous method can be extended to the attribute. As I mentioned, how Pandas store the column data is similar to a dictionary. Each key corresponds to each column header. When Pandas set up the column, it also sets up an attribute for the data object using the same column name. Notice that there is no such correspondence to the row. For example, by typing df.apple, Pandas finds the column apple from the data frame and returns us that column. However, as it is an attribute, there are limitations in the names we can use. We cannot use this method to call columns which contain number, space, or symbol. It does not mean that you cannot use number, space, or symbol in your header. It only means that when the header you want to call contains these, you need to call by the index, like what we did in the last slide, instead of the attribute. Finally, let us exercise on what we have learned today. The manager comes to you again and asks if you can show him how to display a whole column by simply using the index. Can you help him? Again, give yourself 1 or 2 minutes to try it on your own Jupyter notebook. Now let's compare the answer. If you can use the index like the one I showed above, congratulations! This time there is only one way I can find to display that. And I hope the exercises today help you to master all 3 methods well. That's the end of our 3rd tutorial video, and once again thank you for watching this video. I hope to see you again in the next tutorial. We will learn how to ask Pandas to add, edit, and remove entries in a data frame. Again, practice makes perfect. I will encourage you to also read my open source ebook to do some of the related exercises to strengthen your skills. I hope you have enjoyed the tutorial today. See you.